Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to Concept Videos from SOFO Learning. Today we want to explore further into arithmetic progression and learn about the calculation of sum of the first n terms. First, let's recap what is an arithmetic progression. It is defined by two terms. One is the start, which we call A, and the second thing is a common difference, which let's call D. So the progression is basically A plus 1D, A plus 2D, and so on to the nth term, A plus n minus 1D. Now our goal is to take the first n terms and calculate the sum of these terms. So figure out a formula for this one. Now before we go through this calculation, I want to show you something quite interesting. To make this easier, let's take simple numbers. All right, simple numbers 1, 2, 3, 4, 5, and 6. Now it's very easy to see that this is also an arithmetic progression. The starting point is 1 and the common difference is also 1. Right? That's why the difference between all these terms is 1. Now what is interesting here is, look at these two terms. The sum is 7. Look at these two terms. The sum is 7. Look at these two terms. The sum is 7. All right. So what we're saying is 6 plus 1 is equal to 5 plus 2 is equal to 3 plus 4, all is equal to 7. All right. Now how do we find the sum of all these terms? All we have to do is just take this 7 and then multiply by the total number of terms divided by 2. So basically half of them. We have 3 terms here. We had originally 6 terms. When we added 2 each, we had half of it. So we have 1, 2, 3, 4, 5, 6. So 6 divided by 2. All right. This is going to be the sum of the terms. Now imagine if we had to n. How do we do this? All we need to think about is the first term and the last term. So what that is this 1 plus that n times this n divided by 2. Now as long as it is an arithmetic progression, then this seems to be the easiest way where we can figure out the sum of the first n terms. All right. Now how do we kind of apply this in a standardized arithmetic progression that has more than 1 as the common difference? So let's kind of explore that. So in a standard progression, our first term is A, the nth term is A plus n minus 1 times D. All right. So the sum of n terms would be, so remember our idea was first and the last term put together. So A plus this term, A plus n minus 1 times D. So this is the first portion. And then we have n terms in here, so we need to find the half of that. So multiplied by n by 2. All right. So if we were to restructure this, we can just add these a's together. So we are going to get 2a plus n minus 1 d, or half of n multiplied by that large term. So this is the sum of n terms. Now there are other ways to derive this formula. We can use the technique where we can reverse the progression. Let me show you. So along with it we can write 6, 5, 4, 3, 2, 1. So if you add them together, you're going to get this constant term. So it would become these two terms added together, then divided by 2 whole multiplied by n. You can use any kind of technique, but you will ultimately reach this standard formula to find the sum of n terms. Now let's try to apply this into a practical example. So the two examples that we want to try, example 1 would be 10, 15, 20, 25, and the second example would be minus 10, minus 15, minus 20, minus 25, and so on. All right. Now the framework or the formula is half of n times 2a plus n minus 1 of d. All right. So we need to look at these terms. In here, a, this is a, this is a in these two, and the common difference, what is the common difference here? It's 15 minus 10 or 5. This is the d, and the d here is minus 15 minus minus 10, and this we know is minus 5. These two would cancel out and become positive 10, and so minus 15 plus 10 or minus 5. So let's apply this formula here. All right. So half times, let's say n is 100. We are trying to add up the first 100 terms, right? Times 100 times 2 times 10 to a plus 100 minus 1 times what we have here d as 5. Now we have, for this progression, what we get is half times 100, which is the n, times 2 times minus 10 plus we have 100 minus 1 times minus 5. So that's how you essentially calculate. I urge you to do the full algebra at home, but you're going to get here, this is 50 times, this is 20 plus this is 99 times 5, and you get a similar formulation, 50 times minus 20 minus 5 times 99. So there you have it. This is the mechanism to calculate the sum of n terms in an arithmetic progression. Thank you so much.